Hi, good day. Our topic for today is about geometric sequence. What is geometric sequence? It is a sequence in which the next term is obtained by multiplying your preceding term by a fixed number that is called common ratio. So let's try to consider this given problem of geometric sequence. We have find the fifth term and the explicit formula of the sequence 4, 12, 36, 108, and so on. So the very first thing in order for us to solve problems involving geometric sequence that we have first to find the visible variables from the given formula. So take note, our formula is a sub n is equal to a sub 1 multiplied by your common ratio to the power of n minus 1. So let's find those variables that are said to be given. So we are looking for the fifth term, therefore we have to find a sub 5. So this will be question mark. Next is your a sub 1, which is equal to 4. Next is your common ratio, which is, do we have a common ratio given? No, we don't have common ratio. Next is your n, which is equal to 5, since we are looking for the fifth term. So the second step that we are going to do is to find for the common ratio. Again, we have to find for the common ratio. So how to find common ratio? So your common ratio is equal to a sub n over your a sub n minus 1. That means your a sub n is the succeeding term divided by the preceding term. So from the given sequence, we have 4, 12, 36, and 108. So 12, if 12 is the succeeding term, then the preceding term of it is 4. So we have 12 divided by 4, then that is just equal to positive 3. So your radius here, or your common ratio here, is just equal to 3. So since we have common ratio, we have a sub 1, we have n, now we are going to find a sub 5. So the third step is to find the a sub 5 or the fifth term using the formula a sub 5 is just equal to a sub 1 times r to the power of n minus 1. But first, let's have to find the explicit formula. So how to find for the explicit formula? So we only have to substitute the value of r in our given formula. So we have a sub 5 is equal to a sub 1 times 3 to the power of n minus 1. Then this is now your explicit formula. So after finding for the explicit formula, we'll have to proceed in finding for the fifth term. So continue substituting. A sub 1 is 4 times 3 to the power of 5 minus 1. So we have 4 times 3 to the power of 4. So next is you have to simplify. 4 times 3 to the power of 4 is 81. Then afterwards, we have to multiply 4 times 81 makes 324. Therefore, the fifth term of the given sequence is equal to 324. And that is how you are going to find or solve geometric sequence problem. Hi, once again, good day. Our topic for today still is about geometric sequence. So let's have to consider this given geometric sequence problem. Find the common ratio r and first term for the geometric sequence, where third term is 20 and sixth term is 160. Again, always remember that our geometric sequence formula is equal to a sub n is equal to a sub 1 times r to the power of n minus 1. So once there's a problem about geometric sequence, you always have to utilize this given formula. Play with this. So let's continue. Our first step is to list all those unknown variables and the given variables. So we have R, your common ratio is what we're going to find, and also the first term of the given sequence is what we're going to find. Next is to list the visible variables. We have your third term is equal to 20, where n is equal to 3. And your sixth term, your a sub 6 is equal to 160, where n is equal to 6. So after listing all those visible variables and unknown variables, we will now have to proceed on the second step. Let's try to first manipulate finding the common ratio. So in finding the common ratio, we will have to utilize this and we will be making two equations. So manipulate first the third term. We have a sub 3 is 20 is equal to your a sub 1 times your common ratio to the power of n is 3 minus 1. Then we have 20 is equal to a sub 1 times r to the power of 2. And this will be your equation 1. Next, we will have to manipulate the sixth term. Your sixth term is 160 is equal to a sub 1 times r to the power of 6 minus 1. So you have to simplify. We have 160 is equal to a sub 1 times r to the power of 5. And this will be your equation 2. So after finding two equations, we will now have to proceed isolating your first term in order for us to find the common ratio. Let's use the equation 1. So we have 20 is equal to a sub 1 times r to the power of 2. So let's isolate the first term. So in isolating the first term, we have to divide both sides by r to the power of 2. And that becomes 20 over r to the power of 2 is equal to your a sub 1. So we find already your first term. The next step is to substitute your first term to your equation 2. So we have to use equation 2. That is 160 is equal to your a sub 1, which is 20 over r squared times your r to the power of 5. So you have to simplify. 160 is equal to 20 r to the power of 5 over r to the power of 2. As to what you have noticed, we are dividing variables having the same base but different exponent. Therefore, we can apply quotient rule for exponents in order for us to simplify this given equation. So we have 160 is equal to 20 divided 1 makes 20, and r to the power of 5 divided by r to the power of 2 is just equal to, copy your base r and subtract your exponents. 5 minus 2 makes 3. Again, our goal is to isolate common ratio. So we have to divide 20 both sides, and that becomes 8 is equal to r to the power of 3. And we are not done isolating your r because there's still cube. That is why we have to extract cube root to both sides. Therefore, r is equal to 2. Then your common ratio is equal to 2. So this will be 2 here. So since we are done finding for the common ratio, we can now find for the a sub 1. By how? Let's just use this given equation. So we have to substitute r is equal to 2. Therefore, a sub 1 is equal to 20 over r to the power of 2. Your r is equal to 2 to the power of 2. So we have 20 over the square of 2 is 4. Therefore, your a sub 1 is equal to 5. So your a sub 1 is equal to 5. So we are done finding for those unknown variables. Then this is how you will solve geometric sequence problems. Again, take note, you always have to play with the geometric sequence formula in order for us to answer geometric problems. So that's all for today about geometric sequence. I hope you've learned something from this given video demonstration.